All right, we're ready for activity A. It says, get the gizmo ready. Click reset. Be sure proton is selected in the reaction menu. So we're going to click reset down there and make sure proton is selected in the reaction drop-down menu. Here is the reaction drop-down menu. I don't have to do anything because proton is selected, so that's good. So what's next? I'm going to give you a little bit of time to read the introduction and the question. So pause the video, read the introduction, read the question, unpause the video when you're ready to come back for number 1. Pause the video, and welcome back. Click fire proton and observe. What happens after the proton merges into the nucleus? So for this part, I will show you what to do. You're going to answer the question, then you're going to read the paragraph after the question. So it says fire proton. That's down underneath our atom. So you're going to click on this button. You're going to observe what happens to the entire atom. So click fire proton, observe what happens, come back, write your answer, read the next paragraph. Pause video now and do that. Unpause when you're done. Welcome back for number 2. Here it says click reset and click fire proton. So we click reset, click fire proton, and we see a proton comes in, a reaction happens where something comes off, and our proton turns into a neutron. Then it says, based on what you have observed, click on the image, click edit, and write the equation for this reaction in the gizmo and below. So these will be the symbols we're going to use to write in the equation. So we're going to use these symbols to write what we believed happened in the equation. So we come back to the gizmo, we click reset, we click fire proton, we click write equation. So here's the equation right here. So we initially started with a proton right here. That's the initial proton in our atom. But we added something to that. We added another proton when we clicked fire proton. So what is the symbol for a proton? It's an H with a 1/1. So that means our equation, we've added to it, because we've added a proton, 1/1 H. So this is just like an equation. There's our equal sign. So we have 1/1 H equals something. Well, since it's the same letter, we just bring that letter over here, and that's an H. And then we're going to go ahead and add the top row, because now we have 2 particles in our nucleus, 2. That is a bad 2. But we only have 1 proton still, so that's a 2/1. What came off? A positron. So we got to write the symbol for the positron, and if I remember correctly, it's a 0/1 with a lowercase e and a positive sign. Let's see if we're right. So this right here, this whole thing is what we're going to write as our answer in our gizmo right here. To do that, we click edit, or we click on the image, we click edit, and then we know we had a 1/1 over 1H, and that equaled a 2 over 1H, capital H, and a positron E plus. So that was our equation we came up with. The next thing says, turn on show equation. Was your predicted equation correct? Turn on show equation, 1 over 1. And sure enough, we were correct. So that's a good thing. We'll write yes here. Correct your equation if necessary. We don't have to. It says the resulting H2 isotope is called deuterium. It is still hydrogen. It just goes by a different name, deuterium. Then question B, emitted energy is reported in mega electron volts, where 1 mega electron volt is equal to 1 million electron volts. How much energy is emitted in this reaction? Well, where do we find that? That's definitely somewhere on this gizmo, and here it is right here. So that would be the answer to question B.